Here is the Arduino code that I'm using. So at the top, you see it has the include Accelstepper library. Then it creates the stepper object. So that 4 indicates that I'm using an L298, which has 4 wires. Then 7, 8, 9, 10 are the pins those wires are on. And that 1 at the end is optional. In the setup loop, there is a statement set max speed. And I'm setting it to 500. You could set that up to 1,000. They don't recommend above 1,000. And that really is just there in case the motor goes too fast or something. I'm not really sure. Then in the loop, the main loop, you have set speed. So this is the speed. This is the RPM the motor is going to actually turn at. And that's 250. Then you have the move to. And the move to is going to go to the variable position, which I'm going to continue to change. And then you have run speed to position, which is going to make it actually do the move, actually turn the motor. The next if clause is distance to go. So when distance to go equals 0, that means it got to the move to position. Then I'm going to disable the output. That's going to turn the motor off. So there's no power to the motor. So this is what makes this a very efficient compass motor. Finally, in the timer interrupt clause at the bottom, it's going to enable the outputs. That's going to enable the motor to be back on again. Now this isn't actually controlling when the motor is turning or not, it's just controlling power to the motor. So if you know a stepper motor, when it's standing still, it's using a lot of power because it's holding its position. By disabling and enabling the outputs, you stop it from using power when it's standing still. So that's what that does. And what this millis equals max speed start time greater than or equal to max speed duration. That's the timer interrupt. And what's going to happen in there is the position is going to be incremented by 60, which is about 110 degrees. So that's going to enable the motor to turn another 110 degrees. Now also you need to know that in that run speed to position, you can't use accelerate. You can't control the acceleration. It just is at that speed, that set speed, whatever the last set speed was. So that's how the sketch works. So here's the motor actually in action. Let's see how it does. It needs a little assist. So you can see it's starting and stopping. These red marks indicate the north pole of the magnets that are inside that white block. So that will go nicely. And the really amazing thing about it is that the motor, the stepper motor down here, is not actually turning the armature, which weighs 2 pounds. It's only turning the magnets that weigh about 7 or 8 ounces. So the magnets turn a little, and then the magnets try to point north, and that drags around the armature, which rotates. So then once it's rotating, the inertia of the armature keeps it rotating, and the magnet gives it a little push each time. But now because the motor shuts off and on, it's very efficient. So that's my motor. So let me know what you think. Give me a like, a rumble, a subscribe, and stay tuned.